The images and video sequences included in this video are prepared to span 80 degrees of the viewer's visual field. The quality of some results can be affected by video compression. Please refer to the supplementary materials for better quality. Foveated rendering reduces rendering cost by limiting spatial resolution for peripheral vision, and therefore becomes a crucial component of rendering systems for large field of view displays such as virtual and augmented reality headsets. However, too aggressive foveation leads to reduced quality and visible peripheral blur. In this work, we take advantage of a range of spatial frequencies that are detectable but not resolvable by a human. We demonstrate that instead of rendering this range of details, they can be effectively synthesized using procedural noise. Consequently, we can use more aggressive foveated rendering and eliminate the perceived blur using carefully controlled noise. Our method takes as an input a single frame for foveated rendering. Then, it uses it to estimate noise properties such as amplitude and orientation. Next, it applies contrast enhancement to the input frame to restore attenuated spatial frequencies and adds procedural noise to compensate for spatial frequencies that were not synthesized during the rendering process. Here we show another sequence which compares the foveated rendering input, contrast enhancement, and our technique. Adding random noise to a video sequence may lead to temporal artifacts visible even in the far periphery. To avoid such artifacts, we identified noise parameters that should change according to the underlying content, while others are kept constant throughout one sequence. Our enhancement can handle different foveation levels by carefully adjusting the noise frequency and amplitude according to the underlying content. Here, we show our technique applied to low foveation, medium foveation, and high foveation. It can be seen that the noise frequency spectrum changes with the amount of foveation. Our technique can also be applied to stereoscopic content by warping the noise generated for one eye according to the disparity map. Here, we show one sequence using the red sign anaglyph colors. Thank you.